sampling distribution is a collection of statistics, one for each possible sample that might be selected. Let's look at a few diagrams to help us understand this concept. In this diagram, we're looking at a population of 4 people. The population includes a 20-year-old, a 30-year-old, a 40-year-old, and a 50-year-old. We're imagining that a person is taking a random sample of 2 people from this population, recording the ages of the 2 people, and calculating the mean age of the 2 people by adding the 2 ages and dividing by 2. In this situation, the sample of 2 people that's selected could be any of the 6 possible samples shown in this diagram. Person 1 and 2 might be selected, person 1 and 3 might be selected, person 2 and 3 might be selected. The sample of 2 people that's selected could be any of the 6 possibilities shown in this diagram. In this situation, the number that the sample mean comes out to depends on which of the 6 possible samples becomes the actual sample. If person 1 and 2 are selected, the sample mean will be 25. If person 1 and 3 are selected, the sample mean will be 30, and so on. Overall, this diagram is showing the 6 possible samples, and each possible sample has its own sample mean. That means that this diagram is really just showing 6 sample means. The 6 sample means shown in this diagram are the sampling distribution in this situation. In this situation, sampling distribution is 25, 30, 35, 35, 40, and 45. The sampling distribution is just those 6 numbers. It's those 6 sample means. The sampling distribution covers the range of possible numbers that the sample mean could come out to. In this situation, the sample mean has to come out to a number between 25 and 45. In this situation, we're looking at the same population of 4 people. Now we're imagining that a person is taking a random sample of 3 people from the population, recording the ages of the 3 people, and calculating the mean age of the 3 people. In this situation, the sample will be one of these 4 possible samples. The 4 sample means shown in this diagram are the sampling distribution for this situation. In this situation, the sampling distribution is 30, 33.33, 36.67, and 40. It's those 4 sample means. In this situation, a person is taking a random sample of 2 people from a population of 5 people. The person is recording the 2 ages, and the person is calculating the mean of the 2 ages. In this situation, there are 10 possible samples. The actual sample that's selected will be one of the 10 possible samples. Each of the 10 possible samples has its own sample mean, and those 10 sample means are the sampling distribution. The sampling distribution in this situation is just the 10 sample means shown in this diagram. Now that we've looked at a few examples of sampling distributions, let's go over the steps to create a sampling distribution. Sampling distribution can be created by following these steps. First, you list out the possible samples, or the possible combinations. Then you calculate the statistic of each possible sample. And then you organize the sample statistics that you've calculated in a list or in the graph. Here's our first example of creating a sampling distribution. This question says that a population of 4 people has these 4 ages. A person is randomly selecting a sample of 2 people from the population, recording their 2 ages, and calculating the mean age of the sample. We're going to be creating the sampling distribution. The first thing we need to do is take the population and sort it into all possible samples of 2 people. A good starting point is person 1 and person 2. That'll be sample 1. After we pair person 1 and person 2, let's pair person 1 and person 3. Then let's pair person 1 and person 4 for sample 3. Next, let's move down to person 2 and pair person 2 with person 3. That'll be sample 4. Next, let's pair person 2 and 4. That'll be sample 5. Next, let's move down to person 3 and pair 3 and 4 together. That'll be sample 6. At this point, we've listed out all of the possible samples of 2 people. Next, we need to calculate the mean of each of the 6 possible samples. We could do that by just adding the 2 numbers in each sample and dividing by 2. 20 plus 22 is 42, divided by 2 is 21. 20 plus 24 is 44, divided by 2 is 22. We just need to do that 6 times. Once we're finished, we'll have all 6 sample means. Each sample mean is an x bar, so we've calculated 6 x bars. Next, we just list the 6 sample means we calculated over here. And that list of 6 sample means is our sampling distribution. Next, we can plot the 6 sample means that we've calculated in a graph. These 6 sample means are just the 6 sample means that we calculated on the last page. Up here, we have the population of 4 people we started with. We know that a person is taking a random sample of 2 people from the population, recording the 2 ages, and calculating the mean of the 2 ages. We know that there are 6 possible samples, and we know that each possible sample has its own sample mean. The 6 sample means and the sampling distribution are all shown in this graph right here. The 6 sample means are 21, 22, 23, 23, 24, and 25. This down here is just saying that the population mean is 23. Mu is population mean, so this is saying that the mean of the 4 population members is 23. If you add them and divide by 4, you get 23. Mu x bar is a symbol for the mean of a sampling distribution. So what this is saying is that if you add these 6 sample means and divide the total by 6, you get 23. These two numbers always come out to the same number. The mean of the population and the mean of the sample means always come out to the same number. So when a person takes the random sample of 2 people and calculates the sample mean is going to come out to some number, but the number that it comes out to depends on which 2 people are selected. Over here, we can find out the probability of the sample mean coming out to each of these different numbers. One of the 6 possible samples had a sample mean of 21, so there's a 1 out of 6 chance the sample mean will turn out to be 21. One of the 6 possible samples had a sample mean of 22, so there's a 1 over 6 chance that the sample mean will be 22. 2 of the 6 possible samples had a sample mean of 23, so there's a 2 over 6 chance that the sample mean will turn out to be 23. And there's a 1 out of 6 chance that the sample mean will be 24, and a 1 out of 6 chance that the sample mean will be 25. Let's move on to our next example. This example says that a population of 4 people has these ages. A person is randomly selecting a sample of 3 people from the population, recording their 3 ages, and calculating the mean of the 3 people. And we're going to create the sampling distribution. First, we need to take our population and sort it into all possible samples of 3 people. I did that by just leaving out one person from each sample. I left out person 4 from sample 1, I left out person 3 from sample 2, I left out person 2 from sample 3, and I left out person 1 from sample 4. Once I got the 4 possible samples, I just calculated the mean of each sample by adding the 3 numbers and dividing by 3. I did that 4 times. Once I got the 4 sample means, or the 4 x bars, I listed them out right here, and this list of 4 answers is a sampling distribution. Next, I can plot the 4 sample means in the sampling distribution in a graph, just like I did before. These are just the 4 sample means from the last page. Remember, we're taking a random sample of 3 people from this population of 4 people. We're recording the 3 ages, and we're calculating the mean of the 3 ages. In this situation, the sample mean is going to come out to some number, and the number that it comes out to depends on which 3 people are selected. In this situation, there's a 1 out of 4 chance that the sample mean will be 22, because 1 out of the 4 possible samples has a sample mean of 22. There's a 1 out of 4 chance that the sample mean will be 22.7, because 1 of the 4 possible samples has that sample mean. These other two numbers also have a 1/4 probability. This is just saying that the population mean is 23. It's saying that the mean of these 4 people is 23. This is saying that the mean of the 4 sample means is 23. Mu x bar is the mean of the means. If you add these 4 sample means and divide by 4, you'll get 23. This situation is a little bit different because it doesn't involve sample means, it involves sample proportions. In this situation, a population of 4 people has these 4 genders. A person takes a random sample of 2 people from the population. The person records the genders of the 2 people, and the person calculates the proportion or fraction of males in the selected sample. So, to create the sampling distribution, we have to follow the same steps we did last time. We have to sort the population into all possible samples of 2 people, just like before. Next, we need to calculate the proportion or fraction of males in each possible sample. To do that, we just count the number of males in each sample and divide that number by 2. Sample 1 has 2 males. 2 divided by 2 is 1. Sample 2 has 1 male, 1 divided by 2 is 0.5. Sample 6 has 0 males, 0 divided by 2 is 0. P hat is a symbol for sample proportion, so we just have 6 p hats. Once we calculate all 6 p hats, we just list them out right here, and these 6 answers are our sampling distribution. So the sample proportion is going to come out to it's going to come out to one of these 6 numbers. If sample 1 is selected, the p hat will be 1. If sample 2 is selected, the p hat will be 0.5, and so on. Next, we can take the 6 p hats that we've calculated and plot them in a sampling distribution graph. We had 1 p hat of 0, 4 p hats of 0.5, and 1 p hat of 1. Up here, we're just looking at the 4 population members. There was 2 males and 2 females. P is a symbol for population proportion. So this is saying that the population is half male, because 2 divided by 4 is 0.5. P hat is a symbol for sample proportion. So when this sample of 2 people is randomly selected and the genders are recorded, the sample proportion, or p hat, is going to come out to some number, and it depends on which 2 people are chosen. If 2 males are chosen, p hat will be 1. If a male and a female are chosen, p hat will be 0.5, and so on. In this situation, there is a 1/6 chance that the sample p hat will come out to 0, because one of our 6 possible samples had a p hat of 0. There's a 4/6 chance that the p hat will come out to 0.5, because 4 of the possible samples had a p hat of 0.5. And there's a 1/6 chance that the p hat will come out to 1, because one of the 6 possible samples had a p hat of 1. Like I said, p is population proportion. This is just saying that the population is half male. Mu p hat is the mean of all of the p hats in the sampling distribution. If you add these 6 numbers and divide by 6, you'll find out that mu p hat is 0.5. So mu x bar is the mean of sample means. Mu p hat is the mean of the p hats, or the sample proportions. So here's a few important points about sampling distributions. In a sampling distribution made up of sample means, the mean of the sampling distribution equals the mean of the population. Mu x bar equals mu. We saw that that was true in 2 of our examples. In a sampling distribution of sample proportions, or p hats, the mean of the sampling distribution is equal to the population proportion. Mu p hat equals p. We saw that this is true in our last example. We saw that these 2 numbers were both 0.5. The mean of the 6 p hats was 0.5, and the population proportion of males was also 0.5. A sampling distribution has a standard deviation called a standard error. When the sampling distribution has more spread to it, the standard error is bigger. The shape of a sampling distribution is predictable in certain situations, and that's something we'll talk about more later. Sometimes it's possible to predict the shape of a sampling distribution without actually creating it. Also, when a sample is randomly selected from a population, the sampling distribution determines the probability the sample statistic will come out to a certain number. We saw that that was true in our diagrams. We were able to take the sampling distribution and use it to calculate the probability of each possible number that the sample statistic could come out to. And that's all for this video.